So just kind of a review of some of the stuff we've done. And we'll probably review this again tomorrow to start class, because my intentions today was to use this to transition into 3 variable systems of equations. But with so many people gone, I'm guessing it's probably weather related. We're going to do a little bit of a review and other exercise so that we don't start 3 variable systems with so many people out of here. But anyway, looking at this first one, both of these, you could solve them with whatever method you want to. The first one is probably easiest to solve by what method? I mean, the second equation I actually could solve for y and use substitution pretty easily. But I would say that this is the elimination or addition method. If I take this bottom equation and I multiply it by 2, it'll be a 4x and a negative 4x, and it'll disappear when I add them together. So the top equation, I'm just going to rewrite. It does not change. Bottom equation, I multiply by 2. 2 times a negative 2x is negative 4x. 2 times y, 2y. And don't forget, 2 times 11 is 22. Now we add those together. 4x and negative 4x cancel out. 3y and 2y make 5y. 3 and 22, 25. And then we divide by 5 to get y equals 5. Now what do? We have to go back and find x, which means we have to go back to either one of the original 2 equations. I'm going to use the top one since it's all positive. So 4x plus 3y becomes 3 times 5 equals 3. So 4x plus 15 equals 3. We subtract 15. 4x equals a negative 12. We divide by 4. X equals negative 3. So we have negative 3 comma 5. How many of you had that? How many of you have no idea where it came from? Not too bad. That's good. Well, I'll settle for that on the first problem back after, what, 12 days? 11 days, something like that. So anyway, this one here would not be terribly difficult to solve with elimination as well. But because it's set up with no coefficient in front of the y's in either equation, well, I could just multiply one of them by negative 1 and the y's would cancel out. But since we did this one by elimination, I'm going to do this one by substitution. So I'm going to solve this equation for y by adding 2x. So we have y equals 5 plus 2x. And now I'm going to put that in. I'm going to replace this y here with this y, so 5 plus 2x. So 3x plus, and there's no number in front of the y, so I don't need parentheses or anything. It's a positive there. So I could put a plus 1 times this, but that's just going to be 5 plus 2x equals 10. So now I can combine 3x and 2x makes 5x plus 5 equals 10. And then 5x equals 5, and I'm sure you can see where this is going. 5 by 5, x equals 1. And now this is what's nice about substitution. That's why I did this one by substitution, because you get that first variable. This one is set up so you can get to that first variable very quickly. Most of the time, substitution, the work is getting to that first variable. But the reason I did this one by substitution is once you get the first variable, the first, in this case, x, finding the second one's really simple. I just put that back in here for x. So y equals 5 plus 2 times x, 2 times 1. So y equals 2 times 1 is 2, 5 plus 2. So y equals 7. So we get 1 and 7. How many of you got that one? How many just ran out of time? Okay. Any questions on those 2 processes? Okay. days. Like I said, tomorrow we are going to come back to those, and we are going to do them a lot more on a much bigger scale because we're going to throw in a third variable, which means we have to throw in a third equation. Have lots of fun with it. You guys don't look like you're so sure about that.
A third equation.
Third equation, yes. So 3 equations, 3 variables.
3 variables for 2 equations.
Nope. Like if you only have 1 variable, you only need 1 equation. 2 variables, you have to have 2 equations to get a specific answer. 3 variables, you have to have 3 equations. I will at some point give you 5 variables. That won't be great. That'd be like an extra credit question. But it'll be for fun just to see if you can do it. Why not? That's extra credit.
So, is there
He
an
likes
easy,
using this red pen.
is there an easy cheat sheet way to,
We'll discuss something called matrices, which once you get past 3 variables, even matrices can be tricky because the process for finding, it's called the determinant of a matrix. The process for finding the determinant of a matrix gets more difficult after 3 variables. But if you have a graphing calculator, graphing calculators have matrix functions in them. And so if you have a graphic calculator, I'll take a couple minutes to show you how to use it. No, you don't have to get one. You don't need to go spend $120 because it's an extra credit question. Yeah. But if you happen to still have one, a lot of people are required in high school, junior and senior math in high school, a lot of people are required to have them. So if you have one, I'll show you how to use it. If you don't have one, I mean, this is a graphing calculator. For most what TI-84 Plus is not the best on the market, but it's really the easiest, as far as easy to use and versatile, it's pretty impressive. By the way, if you know anybody that has one of these, if you have kids or friends that are in high school that had to buy one for a class, what they give you for the owner's manual with it, they give you like 2 books that are like this thick. That's not the full owner's manual. I actually have the full owner's manual printed out back here. It's 2 3-inch binders. It's 6 inches thick. It tells you everything that calculator does. But the owner's manual only tells you the introductory stuff. You got to download the full one off their website to know everything. Yeah. I don't know how to use everything on that calculator, just so you know. So anyway, there's 2 things we're going to review today. One is an arch. I don't know if you recall working on these, but we did a little bit. For you guys, it might be something like doing a groove or whatever in a piece of material. So your arches would probably look the other way. Let me redo that here. I see my computer is going to be very, very cooperative today. Whether it's an aesthetic part, or maybe it's a fluid channel or something, a drainage, whatever. It's not uncommon to take a round mill, and have to cut a channel in something. So one of the things that's handy to know, let's say that we want to cut this, and this is, let's say this is going to be 3/4 of an inch across, and this is going to be 1/4 inch deep. We need to know what radius to use here, what radius or diameter of a round mill to use here. Do you guys have round-headed mills in the shop down here?
ball?
Yeah, ball end.
Yeah.
You do have them? Okay. I didn't know if they did or not, because I know you guys don't use them a whole lot for anything. None of your projects really require it. So anyway, what we have to do, pretend that looks like a circle, is you have to complete the circle. And okay, we're going to cut it across here, and we're going to cut it in half. Do you guys remember why we cut it in half? There will be 3/8 on each side. You are correct. And we cut it in half because we're going to draw the diameter through here. And the diameter, when it hits a chord, if it hits it at a right angle, and we're going to draw it so it hits it at a right angle, we'll always cut it in half. Now, later on next semester, we're going to learn how to find angles. We'll be able to put in the radius of this, and we'll actually be able to find the angle and figure out what volume of material is removed there. We'll look at some of those problems towards the end of next semester. So anyway, we've got 3/8 and 3/8. This, of course, is 1/4 inch. This up here, I'm going to call x. And remember, x is equal to these two dimensions multiplied together and then divided by this one. Oops, come on, give me my pen. There's going to be 3/8 times 3/8 divided by 1/4. Which is what, 9/16? So that comes out to be? Yes? No? Somebody double check me. I think so. We're going to call it that anyway. So x is 9/16. What that means is the diameter is what? 9/16 plus 1/4. Where did I get those numbers from? Well, 9/16 to here, 1/4 there. We add them together to get the diameter, which is going to be 13/16 is our diameter. So that means our radius is 13/32 of an inch. Does that look familiar?
So you can divide it by a quarter and then add a quarter.
Where? Oh, up here, yeah. Then you got to add that 1/4 inch to it. Yep. We'll do one that's in a little bit easier terms. Because having the quarters and 3/4 and stuff is kind of a pain. Let's say this one is 6 millimeters here. And across here, let's say this is, well, let's go 48 millimeters across. Find the radius of that circle. I'll give you guys a couple minutes, see if you can do it. Okay, so we'll split this into 24 and 24, and this into x. So we've got x equals 24 times 24 divided by 6, otherwise known as what, 96? So the diameter is the 96 plus 6, or 102 millimeters. So the radius is 51 millimeters. How many of you got that? Cool. Yeah, problems 1 and 2 on the worksheet. I want you to try those. Obviously, these are bigger numbers with inches. This was designed for woods, for doing fireplaces and window arches, but it's the same concept. Go ahead and give those a shot quick, and then we'll start talking about rounding to the nearest eighth. So on the worksheet, for number 1, what do you get? 18 and 1/16 is the radius? Is that what everybody else came up with?
Is that what those 625 is?
Yeah, it's 0.0625. Yeah, that's a 16. So 18 and 1/16 inches. Perfect. For number 2, what'd you get? 30 inches. You got it. That works. Okay, now moving down to the bottom of the sheet, especially for you guys, since you're going to be using some trig, finding dimensions and stuff like that, you need to find, once you calculate something in decimals, a lot of times you need to put it back into 16ths or 8ths or whatever. Bless you. So what we're going to look at here is we're getting something to the nearest 1/8 inch, mainly because that's, in construction, you go to the nearest 1/8 inch. So I put this out here for the woods guys, but for you guys, that is a skill. If you're looking, it could be the 1/8, the 16th, 32nd, or 64th of an inch. And the process works exactly the same. So like the first one there, we have 5.73 feet, and I want it to the nearest 1/8 inch. To do that, I first remove the feet. That is now 5 whole feet. And now I have 0.73 feet left. What am I going to do with that? Times 12. Turn it into inches. 0.73 times 12, of course, is 8.76. So 8.76 inches. What am I doing with that? I take the 8. 8 is now inches. See, on my calculator, I'm going to subtract the 8. Now I have 0.76 inches. I'll put that over 1. What do I want the denominator to be? 8. So I'm going to multiply by 8 over 8. So 0.76 times 8 is 6.08, right? Yeah, but I multiplied 1 by 8 to get 8. 0.76 times 8 to get me 6.08. The reason I multiplied by 8 over 8 is because it is 1. So I'm not changing the value, I'm just changing the appearance. So 6.08 is between 6/8 and 7/8. It's obviously closer to 6/8. So 3/4. So if I'm starting out in feet, that's my process. What if I'm starting out in inches instead of feet? Like 89.32 inches. I'm going to put this in the calculator. 89, your register, 89.32. And as you said, Bruce, the first step is divide by 12. So I got 7.43, whatever. All I want off of that is the 7. That's 7 feet. Now I'm going to get rid of the 7, take off the 7. That's subtracting 7 in my calculator. I'm not going to type in 0.443333333 because that would be rounded. Leaving it in the calculator like I just did, just subtracting the 7 and keeping it there, I am keeping it from being rounded off. Now, of course, I got to turn it back into inches times 12. Now I'm going to show you a little trick here. It's 5.32. Where does that 0.32 look familiar from? We started out with 89.32. If I do this correctly, when I multiply it back like that, the decimal should be the same as what we started with. Okay? So I got 5.32, so I have 5 whole inches. Back here, I'm going to subtract that 5 whole inches. Now I have just the 0.32. And if I was going to 16ths, I would multiply by 16, or 32nds, I'd multiply by 32. Here we are going to 8ths, so I'm going to multiply by 8. 2.56. 2.56, of course, means it's between 2/8 and 3/8. 2.56 is closer to the 3. You got it. What do you think? Can you do those two processes? This should be a little bit of review. We've done them before. So what I want you to do for our last 11 minutes here is see if you can finish off that worksheet quick.